you win yesterday?
Okay.
Yeah, first overall. Hey.
I did say that. Okay, please talk a lot. Okay, so here's what's up. We are solving log equations. And the reason I'm kind of making a deal about taking notes on this is because we will do exponential equations and log equations, and we do them differently. And then what's going to get confusing is you're going to say, I don't know which process to use when. So let me be clear on when we do log equations. Number one, the most important thing is it will have the word log in the problem. Already in the problem. You're not going to add it. It will already be there. The word log already in problem, right? So if you have a problem tonight and it's got the word log in it, it's a log problem. The second thing is that it's going to have an equal sign. If it doesn't have an equal sign, it's not a log equation, right? We're going to be solving log equations. And the third thing is it's going to have a variable, because our answers are going to be like just random, easy ass numbers, like a equals 7 or x equals 3/5. Like they're going to just be numbers, right? So we're going to have a variable. So in these cases, the reason you're going to use this process is that, like this one that we're going to do in just a second here he is. He's got the word log already in it, and he's got an equal sign. And there are two types of these to do, right? The good news is they're not either one very hard, and the math is pretty easy. And that's because we don't like the word log in a problem. And our goal is to get rid of it. And I'm going to show you some very easy ways to do it. So the very first type that we're going to do, and you're going to write this down, and then we're going to get to this dude. The very first one is called a type 1 problem. And the type 1 problem goes like this. It will have the word log on one side and the word log on the other side. Only one log on each side. We are going to get some problems where we're going to have more than one log on each side, and we're going to have to deal with that, and it's easy. But what we want is log equals log, and we want one log on each side. So here's why we like this. Here comes the first one to write down. You can do this on your whiteboard, you can do it on your paper. Question is this a log problem? Yes. Is it a log equals log? Yes, because I have one log on one side, one log on the other. And guess what's nice? You get to ignore them. If you have one log on one side, as long as the bases are the same, and they will be, and one log on the other, you get to ignore them. Yay! And you're like, oh my God, that's so easy. 4a minus 7 equals a minus 1. Is it that easy? It is. We're going to go ahead and move that a over, so we get 3a equals 6. And I'm going to say a equals 2. And I'm done. Because I have one log on one side, one log on the other. Now, obviously, we're not always going to get that. So we're going to try some where it's not quite so clean, but it's easy to do. Is everybody okay? Good? Okay. I'm going to thumb through something because I did this in the wrong order. We're going to come back to that. We're going to come back to that one. Here we go. First question is it a log problem? It is. It's got the word log in it already, and it's got an equal sign, and it's got log on one side, log on another. But the problem is too many. I got too many. I need one log on one side, and I need one log on the other. Could you do me a favor? Could you scribble out that 4? That makes this problem really stupid. It's much nicer with just a 9. I don't know what I was thinking. I didn't do the problem. So here's my issue. My issue is this. I got too many over here. I got 2 logs. I got this dude, and I got this dude. So I want you to think about how we talked about condensing them down to squish them down. When they're stretched out with a minus, What happens when I squish them? What happens to that minus? It changes to something else. Not plus. Careful. You're close though. So multiply goes with plus. It's divide. It's divide. So guess what happens here? I'm going to squish this down into 4x plus 5 divided by 5. Are we okay with that? I just squished it down. That's why we learned how to do that condensing and that stretching and that squishing, because now I can do these problems. Do I have one log on one side, one log on the other? I do. Can I ignore them? I can. Let's do this problem. It's an algebra 1, nice and easy. And I'm going to stop talking for a minute, and I'm going to let you do the math there. Here's a hint. Multiply both sides by 5. And if you're like, it's really, seriously, that bad? Yeah. Yeah. Base. They do. They do. And they will. What'd you think? Did you come up with x equals 10? I made it 45 on the one side, subtracted the 5, divided by 4. Are we good? Does anyone need me to do it? Yeah? Okay. Let's step up our game a little bit. Let's get a little bit weirder. How about, look at that. That is a log equals log problem. It's awesome. But I got this little 1/2 here. Could you guys do me a favor? Could you put him where he belongs up here? Watch what happens on this one. Go ahead and put that 1/2 up by the 25. And when you start canceling your logs, think of what 25 to the 1/2 means. Don't like that 1/2 out front, so I'm going to move them up to the top. I like when someone says, oh, like they totally get it. It is a dumb fraction, and a dumb fraction at that. So my software gave you a dumb fraction, sorry. But I like the 1/2, so I kept it. These cancel out. Hey, the square root of 25, that's just 5. Is this a dumbass answer? Sure. I'm going to move that over. Do you get something like 18, like negative 18 divided by negative 4? I get like 9 over 2. Does that seem right? Something like that. If you did 18 over 4, I'm cool with that. If you're a nerd and you went 4.5, you're awesome. You're just a slice of awesome. Yeah? So we're okay with that. So here we go. We got something weird now. So on the next one, I need everyone to put down their pencils because we need to have a little conversation. This was Algebra 2. This is what I did with my students in Algebra 2. I stole this actually from 2 years ago, my slides from Algebra 2. But now we got to talk a little bit of calculus here, or pre-calc. And my little bit of pre-calc goes like this. And I want to talk about this. So here's what I want you guys to do. You're just going to shout some answers out to me. I've got the number, let's see the number 5. There he is. I'm going to get a little exponent. I would like to turn 5 into 5. Someone give me an exponent. Turn 5 into 5. 1, you guys are geniuses. Who needs me? What if I want to turn 5 into 25? So smart, so smart. How about 125? 3. Okay. Let's get a little, you think I'm going to do 4. I'm not. I'm going to do 1. 0. Watch this one. How about 1/5? -1, right? How about negative 1/25? -2. Yeah, you can't do it. You can't turn it into 0 because you can't. There is no x. Once you start going negative exponents, it turns it into fractions. And once you have positive exponents, they get really big. As a matter of fact, 0, if we graph this, remember how we would do this action and stuff like that? 0, we can't include 0, right? 0 is not going to be included when we do this because 0 doesn't work. And as a matter of fact, not only does 0 not work, here's the big important question. How would I turn this guy into negative 25? Because if I tried using a negative exponent, it turns it into a fraction. It turns out you can't do anything smaller, 0 or smaller. Nothing. That never can happen. You can never turn a number using an exponent into a negative number, right? It's why we use exponential stuff in science, because we don't really have negative viruses, right? When they were doing all the COVID stuff, they used exponents because if you have one virus, you have a virus, you could have tiny, tiny, tiny amounts of virus, but you can't have negative viruses. It doesn't happen. The reason I'm telling you this is because sometimes you're going to have to watch and you're going to get 2 answers, and one of the answers may be bad. I'd like you to try this problem with your neighbors. You are going to be X factoring this problem. It's algebra 1, but you're going to get 2 answers, and let's talk about those 2 answers. So go ahead with your neighbors, do it together. Just look, it's log equals log. There's nothing messy. Cancel those 2 things out and move stuff around, but you're going to get 2 answers. And let's talk about it. You're going to move, I have the x squared on one side, so move the 3x and move the negative 3 to the other side. Nice, easy x factoring in a minute. Okay, so here's the big pre-calc change from last year. So when I'm doing this problem, this is what I get. I get 5 and negative 2. To be honest, in algebra 2 and algebra 2 treat, we would have just stopped right there. But here's what pre-calc says. When I plug in the 5, I get like 15, take away 3. I get like 12. It's all good. Yay. I get a positive number. But when I plug in this negative 2, look what happens. I get negative 6 minus 3. I get negative 9. This goo, this middle stuff, it's called the argument, can never be negative, right? Do you have to check every answer? No. Really, mostly just check your negative ones. And as long as, and you don't have to check both sides. You just have to check one side. But if you plug in one of these and you get negative, this is a bad answer. Remember, that's called extraneous. It's bad, right? So we're going to watch for these. I'm even going to tell you on your homework which ones to watch for. So I'd like you with your neighbors to try this problem. You're going to get 2 answers, and here are your choices. Both may be right, one may be right, or none may be right. Give this one a try together. So go get your 2 answers and talk to each other. And if you're thinking, Miss T, am I going to have to rainbow factor? No, you're not. It works nice. And if you want to use X's instead of K's. But honestly, God, this is the only thing that's new in this, like the whole chapter, because and the negative and the square roots in the denominator. That's new. And for the algebra 2 treat kids, that writing logs in terms of others. That's new. Yay. So I'm going to steal my answer in a minute. So I'm watching my friend Andrew up here. He moved this over and he got k squared, and he's got plus k, 3k, and he's got minus 18. Yeah. And he went like this because he's a genius. Negative 18, positive 3, and he went 6 and negative 3, and he got negative 6 and positive 3 is my answer. So my question is, both good? One good, one bad? Both bad? Someone tell me what they think. Both. Someone say it. Who said it? What, Colton, what you said? Both are good.
Yes.
Why?
Because
Yeah, because look what happens. If I plug in this 3 squared, that's all good. What happens when I plug in negative 6 squared? It's positive, so it's good too, right? So
But if it was minus 2,
it would be bad. It would be bad. Beautiful, excellent, you got it. Okay, that's type 1. Go back to your notes. We're going to do type 2. A lot of teachers teach type 2 really crappy. I love type 2, and it's my favorite, and I think I teach it pretty well. So you will like it. Here we go. Type 2. So here's the rules for doing type 2. On type 2, the problem is we're going to have log on one side and a number, some random ass number on the other. The kids in my other class said, can't you, add a log on this side? And I said, you can, but if you do it on this side, you have to do it on this side, so now you have log. And you just go back and forth forever. So this is type 2. You have log equals number. Log equals number. And you know what I like about type 2? We don't do them as logs. Watch what we're going to do. We're going to say, screw this. Let's just rewrite this baby. Let's take the base out of the basement. So write a 3 down. The base comes out of the basement. The answer is the exponent. And the goo goes right here. And look how easy that problem is. It's no longer even a log problem at all. Just take the base out of the basement, give it the answer. So all of these are going to equal very small numbers. Because if I don't, I'm going to get giant numbers. Like if I took 3 to the 15th, it's like in the millions, right? So you're going to get very nice small baby numbers. You're going to like that, right? And then look how easy this problem is to do. We're just going to say 3 equals 9b minus 2. Is it dumb numbers? Yes. 5 equals 9b. Divide by 9. You are done. You are done. So let's try 2 of these and then I'm shutting up. You guys did a great job. I told you it was a chunky day. Okay, so here we go. This is not a log equals log because I have nakedy number over here. This is a type 2, but I always want 1 log on this side. So do me a favor, before we start this one, get it down, squish it, right? Condense it down, and then let's rewrite it. Are you ready? Some of you are just rolling on this. So I'm going to say, wait a second, that's log 8. And I'm going to go 2 times 5x plus 1, because when I squish it, it becomes times, equals 2. And now I'm thinking, screw this. I'm not doing a log problem. I am going to take the base out of the basement. The exponent is the equals. And then and if you want, you can even go ahead and do this. I don't care. I'm going to go ahead and go 2 times 5x plus 1. How does that look? Is it algebra 1? It is. I'm going to make this 64. Watch what I did. I divided by 2, so I got 32. I got 31 over 5. Some of you got 62 over 10, and that's fine. 62 over 10 is a totally fine answer. You got 62 over 10, you're awesome. I love you for that. Okay.
Keep doubling your money.
So we're almost done. Last one, best one. This is a really pretty easy one. It's log equals number. Let's see if I have one after that. I don't want to do that one because I'm lazy. But the problem is, I get this random number that's in the wrong place. right? So could you do me a favor? This is my log thing. This is this weird random number. Could you just move him over? Like, dude, put on the number side. Don't be on the log side. Pick him over to the other side.
No, it's like.
Yeah,
It starts going up so fast.
Yeah, it gets it's like, have you seen that thing where if you put a grain of rice in a...
Maybe it's not like 20, but it's.
Oh, it's huge. It gets really big, like super, super fast.
Yeah.
Here's how I'm getting the 2. I added 7 and added 7. Oh, look what I did. So I'm going to say log 6. Here I go. 4x minus 8 equals 2. And I'm like, screw this. I'm not doing a log problem. The base comes out of the basement. The 2 is my exponent. 4x minus 8. I'm going to stop there because you know how to finish that. It's kind of a dumb problem. I mean, a dumb answer. 36 and 8 is, did you get 11? Something like that? Yeah? Okay. So I'm going to tell you what you're going to do, but there's a correction on number 11, and I need to show it to you. So let me pass out the homework first, or number 12, and then I'm going to show it to you. Your homework tonight is this. Do the even ones plus 2 random other ones. I'd like you to get to 10. The only ones that might have 2 answers have a little star by them, right? So watch for them. So the even ones. So let's start to do the odd ones. And it turns out the odd ones were much harder, so don't do the odd ones. Even in like 2 others, maybe even in 1 of them. So let me tell you for 12. You have them the same.
5, no, it's 5.
5 home people.